Hi everyone, this is lesson 2-1, Power and Radical Functions. Our learning target for today will be for students to be able to graph and analyze radical functions. We have two different types of radical functions, one with even index and one with an odd index, similar to how when we have power functions we have either an even exponent or an odd exponent. If we let f be the radical function, f of x, equals the nth root of x, where n is a positive integer. Your index on your radical, this number right here, has to be positive. If that index or n value is even, your graph is going to look like this. You are only going to have one piece to your graph. It's only going to be continuous from 0 to infinity because you cannot take the even root of negative numbers. So when we look at the domain and range for these types of functions, if you have an even index, your domain and range are going to be from 0 to infinity, including 0, because you cross right at the origin here. Our x and y intercept, because we cross at the origin, are both 0. Our function, like I said before, is continuous only from 0 to infinity. We have no symmetry. The function is increasing from 0 to infinity. Notice we don't include 0 here because the first point is where the function starts and it is not yet increasing. So we do not include the 0, but from 0 to infinity it is increasing. Extrema, our absolute minimum, is at 0, 0. Our lowest point on the graph is at the origin. And we only have one end behavior. We could say the limit as x approaches infinity is equal to infinity. We are not able to approach negative infinity here because x cannot approach negative infinity. I put an arrow and then put a slash through it. X cannot approach negative infinity because our domain only goes from 0 to positive infinity. Since our x values only go from 0 to infinity, it's impossible to approach x equals negative infinity. Here at when n is odd, so our index, or the index on our radical rather, is odd, an odd number, we will get a graph similar to this shape. This function is continuous from negative infinity to positive infinity, from left to right, because we are allowed to take the odd root of a negative number. And so the reason for that occurring is because a negative times a negative times a negative, right, rather than, so I'm taking a negative times a negative number times a negative number. When we multiply three negative numbers, it's possible to get a negative product, versus if I multiply two negatives, I will never get a negative value. So therefore, even roots only work on positive numbers, where odd roots work on both positive and negative numbers for x. So if x and y intercept, if we look at the x and y intercept, this graph also crosses at the origin, so our x and y intercept are 0. Since our domain and range are both negative infinity to infinity, more specifically, since our domain is negative infinity to infinity, we can say the function is continuous on that same interval. Our symmetry here is origin. If you wanted to check your table for this type of function, you would see origin symmetry, and in the table you would see opposite x values give you opposite y values. Our function is increasing from negative infinity to infinity. Even though it looks like it's kind of straight up and down here, the y values are still increasing. No two y values repeat themselves. Our extrema are none. We don't have any extrema because the graph never levels out or reaches a bottom point or a highest point, so you would have no extrema here. In the end behavior, as you go to the right, as you go to positive infinity, the function's increasing, so you're going to positive infinity. And the limit as x goes to negative infinity, as you go to the left, the function's moving downward, so the limit is negative infinity. So these are the two types of graphs you're going to get with your radical functions. Like I said, you'll get a graph similar to this if you have an even index, and a graph similar to this if you have an odd index. In example 1, we're asked to graph and analyze the radical function, and we are given the function f of x equals 5 times the square root. One thing we've discussed in class is that if we do not have an index on our radical right here, you automatically assume that the index is 2, which makes it a square root. So we have, if you want to write that index in, I guess I could write a little 2 here. If we don't have an index already given to us, I can put a little 2 as our index. And we're looking at the function f of x equals 5 times the square root of 2x cubed. Notice that the 2x cubed is underneath the square root. Since we have an index of 2, that makes it an even index, which means our function should only be continuous from 0 to infinity. We cannot have this 2x cubed be negative. So at the very least, 2x cubed has to be greater than or equal to 0, which if I solve this for x to figure out our domain, x cubed is greater than or equal to 0 then, once I divide off the 2 on both sides. And then to solve this for x, I would take the cube root of both sides, and I get x is greater than or equal to 0. Which we already knew from the previous slide that all even index radical functions have a domain from 0 to infinity. So we're going to have a domain from 0 to infinity. Our range then is also going to be from 0 to infinity. Just to confirm that our domain and range are correct, I've graphed this function on my graphing calculator. And if I pull up the picture of the graph, we get something like this. I've graphed this on a standard window, and this is what our graph looks like. And you can see that the graph starts right at the origin here. Okay, we have our starting point at 0, 0, which means that our domain, if we look at the graph, our domain goes from 0 to infinity. The graph starts at 0, 0 and moves to the right infinitely. And our range, the y value starts at 0, our minimum y value is at 0, and then our graph goes up infinitely. Looking at the intercepts, because we cross at the origin, that makes our intercepts for both the x and the y intercept equal to 0. And we need to look at the continuity, and our continuity for this function is going to be from 0 to infinity. Our function starts at 0, so our continuity begins at 0 and goes to infinity. The function is continuous for all x values from 0 to infinity. And we need to figure out where the function is increasing or decreasing. And if you look at this graph, the graph is going up infinitely. So the graph is only increasing, and it increases starting at 0, but not including 0, because the first point you're not increasing yet. And it's going to increase infinitely as we move to the right. So we've analyzed this graph, the domain, the range, the intercepts, the continuity, and where the function is increasing and decreasing. We have yet to do the end behavior. Because our domain starts at x equals 0, we can never do a left-hand end behavior, because we cannot approach negative infinity for x. So I want to only find the end behavior as x approaches infinity, and as x approaches infinity, meaning as x moves to the right, as we move to the right on the graph, our limit is infinity because the y value is moving upward infinitely, or is increasing infinitely, so therefore our limit is positive infinity. In example 1, part B, we will be graphing and analyzing another radical function. This time we're going to graph and analyze f of x equals 1/2 times the fifth root of 3x minus 4. When we graph and analyze radical functions, sometimes it's difficult to type in the radical depending on how high your index is, this number right here. This time our index is 5, and we have to graph this on our graphing calculator by using a symbol under the math menu, which is called the xth root. So if we have an index of x, if we typed this into our graphing calculator, the 1/2 I typed in as 0.5. And then I put a times in between the 1/2 and the radical. Otherwise, you're not going to be able to get this 5 in the proper place. So when I typed this in to my graphing calculator, I typed in 0.5 times, and then I hit a 5, and then I did the xth root, which then once I hit the xth root, it knows to put the 5 where the index is, and then I typed in 3x minus 4 underneath the radical. So I just wanted you to be aware that if you have an index greater than 2 or 3, you have to use this xth root, which is underneath the math menu on the calculator. And it might be slightly different on the Desmos on the iPad, but you could also do on Desmos, I think you could type this in as a power rather than a radical, and you could do 0.5 times 3x minus 4 raised to, and we know the fifth root is the same as the 1/5 power. So you could type it in, if you don't have this x root on your calculator, you can change that radical to a power, a fractional exponent. So I want to look at the graph. So I'm going to go ahead and erase what I wrote here and put the graph in. And if I insert the graph after I've erased all this writing here, so looking at the graph, which I'm going to insert here, looking at this graph of the function, we are going to analyze the domain, range, intercepts, and behavior, continuity, and where the function is increasing and decreasing. Since our index is odd, like we talked about on one of the very first slides, odd indexes have a domain and a range from negative infinity to positive infinity. If you look at this graph, it's continuous from left to right, so there's no breaks in it, so therefore my domain is from negative infinity to positive infinity. My range is also from negative infinity to positive infinity. Looking at this function, it looks like we have an x and a y intercept that are a little different here. We do not cross at the origin, but we cross somewhere in here. We might have to find the domain and or not the domain and range, rather the intercepts algebraically, which I will do on the next slide. Finding the x-intercept, we are going to substitute 0 for y, or f of x, and we are going to solve for x here. To solve this equation for x, I first need to get rid of the 1/2. So I'm going to divide both sides by 1/2. If I divide by 1/2, 0 divided by 1/2 is still 0. Then I get the 0 equals the fifth root of 3x minus 4. I need to eliminate the radical with an index of 5, and I do that by raising both sides to the fifth power. The fifth root cancels out with the fifth power. I get 3x minus 4 equals 0. And from here, I get to solve for x by adding 4 to both sides. I get 4 equals 3x, and then I divide both sides by 3, and I know my x-intercept here is at 4/3. So the x-intercept is at 4/3, which is 1 1/3. That looks reasonable. The y-intercept is a little bit easier because we just plug 0 in for x. So I'm going to find f of 0, which means I get 1/2 times the fifth root of 3 times 0 minus 4. And I get 1/2 underneath the radical here. I have 1/2 times the fifth root of, underneath the radical, I get a -4. I need to find the fifth root of -4 and then multiply that by 1/2. Now, when I plug this into my calculator, when I take 1/2 times the fifth root of -4, it's similar to typing in 1/2 times the fifth root of the function. When we type this into the equation editor, you have to put a multiplication symbol in between the coefficient and the radical. And so if we multiply 1/2 times the fifth root of -4, I actually get this really weird decimal, which is -0.659. Or I could just round that and say approximately -0.7 is my y-intercept. That makes sense because it looks like we're crossing the y-axis at just before -1, which -0.7 is just before -1. We are still asked to find the end behavior of this function. If we look at the limit as x approaches -infinity, because we have an odd index, meaning the index on our radical was an odd number, which it was 5, we can graph this function like so, and we can see from the graph of the function that as we move to the left infinitely, our y value is going down, so we're approaching -infinity. As we move to the right infinitely, as we move towards x is approaching infinity, so moving this direction, we can see that our y value is approaching positive infinity, that our graph slopes upward or is increasing. So for odd index radical functions, you have a end behavior in both directions. X approaches -infinity and y approaches positive infinity. And because that occurs, we can say the function is continuous. The function is continuous from -infinity to positive infinity. So as x goes from -infinity to positive infinity, from left to right, the graph has no breaks in it. So therefore, the function's continuous from -infinity to positive infinity. The last thing we need to address is whether the function's increasing or decreasing from left to right. As I move from left to right, the graph is moving upward infinitely. So we would say the graph increases from -infinity to positive infinity. There's nowhere on the graph where the function is decreasing at all, even though there's this little blurb right here in this region that I'm circling, where it's just increasing rapidly, which it may look like it's constant there, but it's not. It might look like that it's vertical, and it's not. It's the y values are increasing. If you look in the table of values on your calculator, you can see that for each x value, as x increases, y is also increasing. So we can say the function is increasing from -infinity to positive infinity. On this last slide, we're asked to check for understanding. We are given a function here, f of x equals the negative cube root of 8x squared minus 4. You can treat this right here like a -1 as your coefficient. And you're asked to find the intercepts of this graph. And I want you to do so algebraically and then choose which one makes sense, which answer makes sense. There's a multiple choice here, A, B, C, and D. A has an x-intercept and a y-intercept. B has two x-intercepts and one y-intercept. C has one x-intercept and one y-intercept. And D has two x-intercepts and one y-intercept. Go ahead and graph this function. Look at the graph so you have an idea of how many x-intercepts and y-intercepts you actually have. You can eliminate some of these answers then from the choices, and then go ahead and find your x-intercept or intercepts and y-intercept algebraically. When you are done, submit your answer, A, B, C, or D, and you are finished.